For 100 years, science assured us that nothing could pierce the cosmic dark ages. That silent, starless dawn after the Big Bang was supposed to be the universe's deepest sleep, a time before creation took its first breath. But then, James Webb looked deeper, and the silent shattered dot, the James Webb Space Telescope, humanity's most powerful eye on the cosmos, has found something that shouldn't exist: gigantic, blazing galaxies and mysterious light beacons where only emptiness was meant to be. Some of these ancient giants were born just 300 million years after time itself began, and others, impossibly, even closer to the very beginning, earlier than theory allows. If these results hold true, then everything we thought we knew about the birth of the universe is suddenly in question. Our cosmic rulebook may be about to burn. So, what did Webb actually see? And why does it threaten everything we believed about creation itself? The story begins at the dawn of time. The universe was born in fire, a furnace of unimaginable heat and pressure, brighter than 1,000,000,000,000 suns. But when that first flash of the Big Bang faded, silence took over. Hydrogen and helium, the simplest elements, drifted across the void like invisible fog. There were no stars, no galaxies, not even a single spark to break the endless night. Only a sea of neutral gas cooling as space itself expanded. Temperatures dropped to a few dozen degrees above absolute zero. Darkness ruled, thick and absolute. Even the faint whisper of the Big Bang's afterglow faded to near silence. For millions of years, nothing happened. Gravity worked quietly, gathering the faint wisps of matter into invisible knots. Each atom of hydrogen floated alone in the black ocean of space, untouched by light. This was the cosmic dark age, a time when the universe itself seemed frozen in stillness, waiting for something, anything, to ignite. Astronomers thought they understood this era. Supercomputer simulations painted a clear picture. The early universe was patient, slow, predictable. According to these models, invisible halos of dark matter acted like cosmic scaffolding, pulling hydrogen and helium inward through gravity. Over tens of millions of years, these invisible wells grew denser and hotter until, at last, the first stars were born. But it wasn't supposed to happen quickly. Only when a halo reached about 100 million times the mass of our sun could it cool enough for nuclear fire to ignite. The first true stars, called Population 3, were expected to appear roughly 500 million years after the Big Bang, faint, small, and rare. No massive galaxies, no bright clusters, no complex structures, just fragile pinpricks of light scattered across a sleeping universe. In this cosmic blueprint, creation was meant to unfold like a slow sunrise, not an explosion. The rules were clear. The timeline, unbreakable. Until Webb proved it wasn't. In 2023, astronomers confirmed something astonishing. A galaxy so bright, so developed, that it broke every model ever made. Its name, JZGSE140. Its light began its journey toward us just 290 million years after the Big Bang, and yet, this galaxy isn't faint or fragile. It's brilliant. Its ultraviolet brightness, measured at MUV equals -20.8, rivals galaxies a billion years older. That shouldn't be possible. Webb spent nearly 10 hours locking onto it, its most sensitive instruments capturing the faintest flicker of light across the void. And when the data came in, there was no doubt. The sharp drop in its spectrum, a clear redshift of 14.32, placed it squarely at the edge of time itself. But what shocked scientists most wasn't its distance. It was its maturity. The galaxy spans just 260 parsecs across, compact, yet shining like a beacon. Its ultraviolet colors show signs of dust, which means generations of stars had already lived and died within it, spreading heavy elements across its gas. In other words, this galaxy was already old, in a universe barely out of its cradle. According to every simulation, that level of complexity should have taken hundreds of millions of years more to form. Yet here it was, fully formed, impossibly early. It's like opening a baby photo album of the universe and finding a fully grown adult staring back. But JZGSE140 is just the beginning. A team led by Pablo G. Perez Gonzalez at the Center for Astrobiology in Madrid pushed Webb even deeper into regions of space so distant no light was ever expected to reach us. Using the deepest JWST NIRCam imaging ever taken, reaching a faintness of 31.5 magnitude, they found something extraordinary. 9 mysterious light sources in a patch of sky that was supposed to be completely dark. 6 of these objects appeared at a redshift of around 17, and 3 at an unimaginable 25, meaning their light began traveling just 100 to 200 million years after the Big Bang. That's not supposed to happen. At that time, the universe should have been a blackout, silent, lightless, empty, and yet, there they are, 9 ancient beacons shining from the edge of eternity. Something is wrong with our cosmic story. Either the universe learned to build stars and galaxies 100 times faster than physics predicts, or there's a missing chapter, something deeper, stranger, and older than we've ever imagined. The James Webb Space Telescope may not just be showing us the first light. It might be revealing a universe that was never truly dark at all. The discovery didn't rest on luck. It relied on one of the most powerful tricks in modern astronomy, the dropout technique, a method that finds what's invisible. Here's how it works. Distant galaxies vanish from blue filters, but shine in red. That disappearance, called the Lyman break, marks where hydrogen gas absorbs light, cutting a clean edge through the spectrum, and the farther away a galaxy is, the deeper into the infrared that break drifts for these 9 mysterious light sources. That telltale break landed squarely in Webb's F to OOW and F to 77W filters, proof that their light has been traveling for over 13 billion years, from distances no telescope has ever confirmed before. To catch them, scientists combined data from Webb's MIRI, NIRCam, and NIRSpec instruments, stacking an incredible 160 hours of exposure, the deepest look into the past humanity has ever taken. What they found left even the most seasoned astronomers speechless. These weren't faint, struggling sparks. They were bright, compact, and impossibly mature. If these are truly galaxies, they're forming stars at rates that break every cosmic prediction. Their ultraviolet light is so blue, some with a spectral slope of -3, that it suggests something unheard of, either pristine, metal-free stars, untouched since the Big Bang, or an entirely new source of energy lighting the darkness. Even their numbers make no sense. At a redshift of 17, there appear to be about 10 squared galaxies per cubic megaparsec, and at Z approximately equals 25, roughly 10. That's 10 to 100 times more galaxies than any computer simulation has ever predicted. The rulebook said the early universe was supposed to be patient, a slow architect, stacking matter grain by grain over hundreds of millions of years. But Webb's data shows the opposite. 9 blazing beacons, shining through the fog when the universe was barely out of infancy. Their compactness, their extreme colors, their staggering abundance. Together, they whisper the same message. Something fundamental about the early cosmos doesn't add up. To explain this impossible brightness, scientists are now reaching beyond the edge of known physics. Some believe these may not be galaxies at all, but the light of primordial black holes. Theoretical astrophysicist Andrea Ferrara has spent years exploring that possibility. His models describe what happens when black holes, born mere moments after the Big Bang, become surrounded by dense clouds of gas. As that gas falls inward, it heats and releases energy, turning each black hole into a cosmic lighthouse, glowing steadily in the darkness. Ferrara's calculations reveal that even if just 1 in every 100 million units of dark matter took the form of such black holes, each about 10,000 times the mass of our Sun, their combined radiance could perfectly match what Webb has seen at redshifts 17 and 25. If that's true, the first lights in the universe weren't stars at all. They were black holes feeding in the dark, gravity itself becoming the universe's first source of illumination. The cosmos, it seems, may have awakened not with fire, but with hunger. But Webb's revelations didn't stop there. When astronomers analyzed the shapes of galaxies in its earliest deep fields, they noticed something stranger still. Out of 263 ancient galaxies, roughly 60% spun clockwise, while 40% turned the opposite way. At first glance, it's just a statistical quirk, but the odds of such an imbalance happening by chance are less than 2%, and the pattern persists even at redshifts beyond 2. That means the asymmetry isn't local. It stretches across billions of light years. It's as if the entire universe has a preferred direction, a built-in cosmic twist. For generations, cosmologists believed the universe was symmetrical, that on the grandest scales, it looked the same in every direction. But now, that sacred symmetry may be cracking. Some researchers think the bias could be a relic of the universe's birth, a leftover spin from the instant of creation itself. Others suggest something even bolder, that the entire cosmos once rotated, and that rotation still echoes through the galaxies today. If that's true, The consequences are staggering. A rotating universe could one day collapse inward in a final big crunch, or perhaps, more radically, our universe might actually lie inside the event horizon of a gigantic rotating black hole, its spin defining the structure of everything we see. And then there's the most provocative idea of all, that we live in a multiverse, where every pocket universe is born with its own unique spin, each turning in a different direction, each riding its own physics. For now, only deeper Webb observations and future telescopes can reveal which story is real. But one thing is certain, the universe we thought we understood, slow, symmetrical, predictable, is gone. In its place stands a cosmos that's faster, brighter, and far more mysterious, a universe that refuses to obey the rules we wrote for it, a universe still whispering secrets from the dawn of time. And as Webb stares ever deeper into that darkness, one truth grows impossible to ignore: the deeper we look into the beginning, the less we understand about the end.